can go ahead.
Okay, welcome to the Data Centered Leadership Podcast. Today we have an incredibly exciting guest. His name is John Sosa. He is the CEO of Mipar. Mipar is an advanced image analysis software that's enabling materials scientists, life scientists, and some other scientists in the world today to analyze images much more quickly and easily than they ever could have before. And it's helping to enable scientific advances to occur more quickly. John started out as a material scientist and worked to progressing to becoming this amazing innovator. So welcome, John.
Thank you so much.
And thanks for coming. So first of all, I'd like to get started by asking, what was your inspiration to develop the first version of Mipar?
Sure. Firstly, Tyler, thank you so much for having me. It's a pleasure. It's great to have a platform to share my experiences coming from the university space and starting up my own business, and not only revealing the story, but the things that I learned along the way that not everyone always tells you straight up. So the inspiration for Mipar was it was interesting. I mean, I started as an undergraduate in the material science program at Ohio State University. I started doing research or wanting to do research as I began my junior year as an undergraduate, and I was very fortunately but randomly placed with my faculty supervisor, and looked him up, set up a quick face-to-face meeting, and asked if he could use any help in the lab research-wise. And he said, "Can you start Monday?" I said, "Great, yes I can." And I came into the lab that Monday and kind of learned a little bit about what the group is really focusing on. And he's a big name in titanium metallurgy. He's been doing it for over 40 years as a professor in a couple different universities. And at the time, the big push was really the pioneering research group to go after what's now called ICME, or Integrated Computational Materials Engineering. It has to do with working to extract data from materials in various ways, put those into a computer, and develop correlative models between that data and then other data about how the material behaves. So for example, correlating the size and shape of features that are in a material at the microscopic level to how strong or flexible the material is, so that you can, the holy grail would be that at the end of the day, when a new airline manufacturer comes to want to put a new, use a new material for a particular component, and they come to you and say, we know it needs to be titanium, and it needs to be this strong and this flexible, then with these models, you can quickly say, okay, I know it needs to be this alloy chemistry, and you need to heat treat it for this amount of time to get there, and kind of short circuit a lot of the trial and error that usually comes with the traditional way of optimizing materials for an application. So all that whole ICME relies very much on quantifying various aspects of a material, and the big one is image analysis of microscopic images of this material. Right. So titanium is a beast in that it can have various features in its microstructure. Basically is the micro components, the different ways that the atoms can be arranged in the material, the different basically a material at its at least a crystalline material like metals, like titanium, at its microscopic level is comprised of different phases. And those phases, two phases, simply differ either by how the atoms are arranged and or the composition, the different elements of atoms that make that phase up. So titanium can have various phases. You can mix it with different things, and that can produce different phases. You can put it in the furnace and hit it with a hammer and do that for various amounts of time, and that can affect the phases that you get. And then not only the amounts of those phases, but the size and shapes of particles of them within the material. All that is part of the microstructure, and that has a big impact on how the mechanical property, the quantification of these titanium microscopic images, really put titanium looks under the microscope. And at the time, we were trying a few different tools in the group, and none of them sufficed. None of them were robust enough. None of them were flexible enough to let us customize them to do exactly what we needed. And there wasn't a clean way to then batch execute the analysis algorithms on the hundreds of images that we had to analyze. So they learned, my supervisor and group members learned that I had some software development experience from a Cornell, from a variety of places, but I really got excited about it at a summer, basically it's called an REU, a research experience for undergraduates at Cornell the previous summer, where I got really hands-on with a few different computing languages for doing atomic simulations of atoms in a material. And they said, well, we've been thinking about custom writing our own tool for this. Do you want to take a shot at it? So I tinkered around with it, got really excited by it once I started producing something that gave some immediate results. It was obviously still a very early stage thing, but it was all, it was at the core, it was designed to be a flexible yet rapid algorithm development environment that would let us, without code, graphically string together image analysis tools to do what we needed, and then also facilitate batch applying that algorithm, and then also facilitate visualizing the results of that batch before you made the all-important measurements. And it's interesting that those three key components, the rapid, very visual, graphical algorithm development, sort of an algorithm playground, the easy batch application, and the batch review and quality assurance are still three core elements of the software's DNA today. So I guess that's kind of where it all got started.
When you say it like that, it sounds like you started with a really high goal for an undergrad, and you really managed to pull it off. That's impressive.
Yeah, it was very much more about the group. I mean, they were, the support I've been given by my supervisor, who is a co-founder in the company now today, is unparalleled. And none of this would have materialized the way that it did without his support and his freedom that he gave me to explore this, this whole project of the software development really has always been more of a side gig. It was done either, from a bit of his discretionary funding that he had available and on my own time. And then it was really more than the environment of the group and the projects they provided me, on the clock. The research projects that I had going, I was able to apply this software iteratively as I developed it, and that just gave it a very unique development cycle, and really spurred the development on, because I was constantly using it, which kept the excitement up because I was immediately seeing the results of the coding effort, and then it also illuminated deficiencies, bugs, ways to improve it. So that constant iteration, I think, was a big part of how it developed.
That's really nice. You kind of had customers, and you also had massive support from the beginning. I mean,
right
that's
from the get-go.
Invaluable
Mm-hmm.
to have that feedback. I mean, that was the next question I was going to ask. How did you ultimately end up deciding to try to sell Mipar?
Yeah, I think you nailed where it began. Within the group, our research group was 10, 12 folks at its peak. And I viewed all of them as valuable users that could provide feedback. And kind of always in my mind as I was developing this thing, I was always imagining others using it. And they were kind of the persona in my mind for this. And then they actually got their hands on it. That was very exciting. They were using it themselves. My supervisor had a lot of connections, still does, all over the world. And a lot of those professors and their students got very early copies of this thing before it being a vision, or, a product in our minds was the case. And that took it to the next level, once it kind of got one hop outside of my own research group, then it really started to crystallize that, okay, maybe this thing is more than just an internal tool. So we began treating it as such, or my development took on that vision a little bit more strongly. And as I graduated with my Ph.D. and I was a postdoc, still again, mostly on the side and on my own time, I was working on this thing to take it more, clean it up, make it look more like a product, really make sure that all of the holes were buttoned up. And we, in the beginning of halfway into 2016, we decided to try to sell some beta licenses of it. And that's when we got involved with the Technology Commercialization Office at Ohio State, the TCO. They had a very helpful gentleman working there at the time who his passion was software, especially early stage stuff, and really taking it from even just an idea to something to commercialize. And he had pioneered this kind of internal Ohio State app store called the Buckeye Vault. At least that's what it was called at the time. That was a platform where folks, smartphone apps or even recipes of all kinds of, just ideas, basically algorithms, could be sold for small amounts of money. And we were certainly a bit of an outlier in that store because our beta licenses were in the several hundreds to even thousands, but it was still a platform that, was effective in letting folks come in and swipe a credit card and sign a license agreement and then download the license in the digital media. So that was a great platform that helped us start putting this out there in exchange for some funds. And that took it to the next level. We started now when even if you sell something for $1, it's amazing how different it is than selling it and just giving it away. Just the expectation on the customer end, the responsibilities on you, it all changes. Wow. Even if the cost goes from 0 to 1. Wow. And that, obviously that started our thinking that, okay, maybe this can be a business or part of one. So for the next half of the year, we kept working on the beta program, we got the website going, started, just without even knowing it, learning the ropes of working with customers and dealing with selling into customer sites and registering as a vendor, and just all the parts and pieces of starting to have a software sales business to business type model. And this was all done still out of Ohio State. We were still Ohio State, or the Ohio State Innovation Foundation was the entity that it kind of is, that wraps the TCO. So that's who we were registering as a vendor as with these various customers. And that's, who they knew the software to be sold from. So by the beginning of 2017, we had maybe 6 or 7 months of the beta program done. We decided, let's call this thing V1 and start selling it outside of beta. and we got more interest, more customers. That it was a combination of really just word of mouth, some couple of conference presentations I did. Our existing customers were publishing papers. We did some light social media marketing, but nothing too heavy. It was really just an organic type of growth. And then halfway into or before that, maybe the first quarter of 2017, we were doing well with this V1 sales out of the university and realized, okay, I had to fire, and I decided I'm going to give this a shot. Started working with the TCO to arrange a license agreement to license the technology to our newly formed company, Mipar. And then by the middle of 2017, all that was in place, and we were out on our own. We got a small office space, and I started it up. Ended up getting we had existing customers, we had projected customers. I, shame to admit, Googled business plan and tried to throw one of those together and put that in front of some underwriters at a local bank, and got a $50K small business administration loan and a couple of credit cards with lines of credit, and just used that to get the office, hire a couple of initial employees. And he took on a few tens of thousands of debt right away, but we knew that we had sales coming in, and we were able to clear that debt out even before the end of the year, and turned a profit in our first half year in business, which was just so fantastic relief. So, yeah, that was kind of the path.
Sounds like you must have been working really hard. I mean, you had the research job, and you also worked on the software. I mean, you make it sound like such a natural progression, but I guess it's only natural when you're laser focused and you work really hard the entire time to find the resources.
Yeah, on one hand, I guess I want to feel like it's a path that anyone can take if they want, and I believe that it is. At the same time, it's certainly a lot of very fortunate things that lined up for me. The research efforts that I had going on in the group, the support of my advisor, the few software development skills, I guess, that I came across during my path, and just, I guess, my, for whatever reason, the passion that I felt for this particular project and the excitement that I got from it just all kind of came together to make this happen. So, and I guess that's
that passion and that excitement. Yeah, definitely. I think that's everything.
I think that you're right. That is the biggest thing. So that's to say that if you have that passion and that excitement about something, then you've got the key ingredient. You've got the most important piece of the puzzle. And if you just find the right support environment and the right set of resources, then you've got what you need.
The passion, the need, the resources. Yeah, that's well. Thanks for sharing that. So, I also wanted to ask what kind of efforts. I mean, you elaborated a little bit on going from the university sales system to buying the university out, kind of, and then taking a risk, getting a loan to grow. What other kind of efforts have you made to achieve consistent growth and profitability over the last 4 years?
Sure.
3 or 4 years.
Yeah, that's a great question, and it's great to be asked, because it forces you to kind of reminisce and figure out, what have I been doing actually? Because I know every week kind of turns in the startup life. Time is ridiculously fast, and weeks go by like days, and months go by like weeks, and years go by like months, and it's incredible. So you do have to. At the time you felt like you were thinking everything through, and you had a plan and a purpose. So to look back and kind of sum it up for yourself as to what have you done to get to where you are is really a nice exercise to go through. So I appreciate that question. Uh, it's really been a combination of continuous tech innovation. We're never satisfied with the product. We're always taking what our customers are telling us about it, good or bad, and moving it forward. And then we're always working on the direct sales side of things, refining our sales process, trying to maximize the efficiency of, trying to minimize time waste and make sure that when we're spending serious time on a customer, that there has been good give and take on both sides, and we're not being taken advantage of, as free consultants or something, which could happen in this particular type of business model. So really just having a streamlined and efficient yet caring use of our time. I mean, we want to put our valuable time to customers, and have that really make an impact for them. So it's been refining that sales process to do direct sales, certainly refining our internal workflows in how we work together as a team, making meetings as efficient as they can be, making sure that we're keeping everyone excited and working on tasks that they're passionate about. In a small group, we're five full-time now with a part-time consultant. It's a family, so everyone has to be really in that same mindset. Of course, everyone's their own person. Everyone has their own personal motivations and their own tendencies and work styles. But all of these, I couldn't ask for a better team, and everyone is here, and they could be doing something else because they've all got incredible sets of skills. And just the fact that they're here and doing this tells me that they're the right people for the job. So it's just about keeping them motivated and making sure that we're all still doing this because we love it. And then the developing of partnerships, I guess, would be the fourth thing. So we've got tech innovation and development. We've got refining your own outgoing direct sales process to customers. We've got refining and optimizing your own internal processes as a team, and then developing partnerships to expand your exposure to folks, and basically grow your own sales staff without hiring employees to do so. So we connect with software-only distributors around the world. We connect with hardware manufacturers that sell either microscopes or imaging equipment or add-ons to that imaging equipment, and they package us with their products to their customers as a means of giving them a complete solution. Because oftentimes folks that purchase a microscope don't just want to look at the pictures, they want to actually get data out of the images and take an action on that data. So if the microscope companies can kind of demonstrate the microscope with the tool, with the analysis intrinsically tied to it, then it looks like they're not just purchasing an electron microscope to take an awesome picture. They're purchasing a thing that gives them an accurate particle size of their stuff, which is where the value is in the application of that microscope. So being part of that complete solution is good for us. It's good for the partner, and that's when partnerships happen. So that's been, I mean, this year we've gathered probably the most number of those partnerships, distributors, OEM packagers, and some other co-marketing efforts. So
wow.
Yeah, that's we're still a bootstrapped startup. We're growing on our own sales revenue. So selling the product one way or another is is where our capital comes from. It's where our business expenses come from, and it's when you're basically, it's a strange analogy, but it always kind of feels like you're hunting for your own dinner all the time, right? So that definitely shapes how you're where you spend your time and where your commitments are. And every one of us does technical sales. Of course, I've got hats of all types. I got my hand. They're still closing accounts. Our lead business guy is, obviously not as an expert in the software, but knows it very well, and is more experienced on the business and sales and marketing side of things. So there is usually a teaming on accounts when it comes to working with customers, and that he'll have the initial conversations and learn what their real problems are and make sure that they're a good fit and that we're a good fit for them. And then maybe the technical guys come in and learn even more about their problem, and then use the software to help configure a solution just for them. Make sure that it meets the justification, give them the solution, and then stay connected to them as they use it, and keep supporting them. So, and then we have another business guy who also helps out with everything else that the senior business development and marketing guy does. And I guess I should also mention the part-time consultant that I mentioned before is fantastic, and it's been a big part of how we've optimized our sales process. He is a business development consultant professionally. He's done this for a long time. We got connected to him through Ohio State University, and he's put us through a rigorous workshop on business development. And it's all about learning each module of his workshop has a different theme. The first is planning. So first you have, basically planning how you are going to present. What do you think the customer of your product needs? You kind of make up a persona and you envision what you think their needs are. Then you plan how your capabilities connect with those needs. You get that plan in place, then you have to move on to reaching out and connecting with actual customers, and then you work on engaging with them and really finding where your plan and where your hypotheses fell apart and where they were true, and adapting to that, and then moving into the negotiation portion where you're closing the deal and you're figuring out how, if their budget doesn't match maybe the cost of your software, are there things that you can trade other than dollars to keep everyone on an even playing field and getting the most out of the deal on both sides. And that's when you get a close. So that whole process of really, the theme was really for us that you spend more time talking and learning what the customer really needs before you jump right in to crazy technical their application and their value. A lot gets missed, and we learned that it's much better to have those early conversations, understand exactly what they want to see, than if we assess that it's a real serious account and we have a clear project plan in place where we're going to get from if we do A, B, and C, we've got it. Then we take some time, spend time working through those proof elements that the customer needs to see, arrange a second or third meeting, present them to them. If we need to iterate, we can, and then once we've met their expectations and we've met the requirements, we're good. So sometimes that's that's been the biggest change in our sales efforts from before to after we worked with this biz dev consultant was that type of refinement,
Wow.
changing from more of a flying fingers demo to more conversations early on, and making sure that our demos are all structured around the customer's particular application and needs, and not just to see what sticks to the wall when we whip.
So it's like your software. It's kind of like business to business. I mean, even if you're selling it to a
Absolutely.
school, it's like
Yes.
you're selling to businesses, and the business to business sounds like kind of a fine dance, and you learn part of it when you first went from giving it away to even charging a
Mm-hmm.
dollar, who knows what. But then, and then as you started focusing more on the growth and you moved out of the university, you had to kind of change your hat or put more focus on that sales hat and the management
Mm-hmm.
hat.
Mm-hmm.
But if it wasn't, but by getting a consultant, by reaching out and finding the right business consultant, you were able to kind of learn some of the intricacies of the dance and ways to take advantage of different potential customer opportunities to make the money more efficiently, to make the sales more efficiently.
Yeah, I think that sums it up beautifully.
Yeah, it's a really interesting personal growth story. Honestly, it's how you go from your passion
Mm-hmm.
to becoming the CEO. Okay,
Mm-hmm. Mm-hmm.
thanks for sharing.
Sure.
Last, I'd like to ask you, what is your vision for Mipar's future?
Yeah, that's a good one. Again, I really appreciate that question, because it's so easy to get in the weeds in the day to day, and you gotta poke your head up and remind yourself where you're going and what you're doing, and are your day to day firefightings moving you towards those goals. For us, it's really about, I would say, hopefully it doesn't sound too cliche, but it's about being industry standard in these fields that we're growing in, starting with material science. Um, Life science is an interesting animal. It's a different competitive space, and there's the whole FDA approval side of things that differentiates kind of diagnostic tools from research tools in life science. So becoming the industry standard in life science is a trickier thing to define. But we're certainly making an impact there, and we're helping users automate analysis problems that they either couldn't before without spending hundreds of thousands in time, which can be an interesting thing to discuss with folks, especially in the academic space. I will say that there isn't always a recognition that time is money, and sometimes folks are willing to let their grad students spend hundreds of hours circling things in a free tool and still claim that the tool is free. And sometimes you have to get into a bit of an economics discussion, of course, in a respectful way. But the where was I going on the side of, so on the industry, on the life science side, the industry standard thing is different, but we're making a big impact there. I would say that our commitment first is to be the industry standard in the material space, both in academia and commercial. The software being as easily configurable as it is to solve the challenging problems in the commercial space is what's helped us get the level of adoption that we have. And once you're in there proving yourself as the tool that can solve all the hard ones, then I think naturally you really take hold, and when folks know that you do something well, and especially when it's something difficult that a lot of uh, a lot of companies can struggle with. You'll find each other, and you can even then be adopted once they have you in place to do the hard problems. You can easily be adopted to solve the easier ones too, and in that way be kind of the go-to tool um, for a lot of these materials analysis efforts that are going on in various companies. And on the academic side, the software itself is outrageously educational, just in the way that you can build your own algorithms totally visually without coding, and you can see every step of what you're doing, and you can always go back and make a change and see what that change did. And you can tinker with different filters and do different what if scenarios and find different ways to solve the same problem with explanations of what each tool is doing along the way. You can share those algorithms with folks. They're 5 kilobytes in size. You can email them around. We've got self-learning platform, a self-paced Udemy course called Mipar Academy out there that is hours of quality footage showing different algorithms being built, and in that way revealing different thought processes that you can go through to solve different problems with the tool. And we've had courses at Ohio State that have adopted it into their class, and it's been a really nice change for them, going from kind of what is the current go-to tool in academia, which is ImageJ. Moving from that to Mipar has been really great for their course, and we're seeing more of that happen. So that industry standard push in academia and university for the material sciences is our first big goal. And of course, like, life science is still there. It's still growing. It's not as clear to me where that's going to take us, but it's still doing good business, and we're solving good problems and making an impact there. The latest exciting push is in the drone space, where with the addition of deep learning to the tool that just came out in our latest 3.0 release, where folks can now circle things in the image and have the software learn how to recognize them without doing anything more than circling them. That's been phenomenal, and it's even let us solve problems that we couldn't before. I mean, we always like to say kind of that if you can see it, you can teach the software too, and that usually was the case before deep learning.
Yeah.
But there were some problems that, for example, I'm not sure how many folks are familiar, but twins in grains is a remarkably challenging problem. Being able to, because you've got these things that sit inside grains that look like grains themselves, but they're not. And you can't really see the grain until you piece these different polygons together in your brain and find the pattern that makes kind of a hexagon type shape. And having the computer do that with a traditional image analysis workflow was honestly impossible for us. And we could only make kind of a real semi-automated solution for that in the past. But with this deep learning technology, we were just able to circle the grains that we saw, or trace them carefully over a few different images, and then let the software cook on those on a graphics card overnight, and it comes back with a predictive model that you can run on a new image. And it started finding the grains as our brains did, and then our jaws were on the floor. And that solution now is being adopted very heavily by the various companies that used to do this type of grain analysis purely manual, or use really expensive imaging equipment and technique called EBSD to do this before. That would take 2 hours a sample and cost $500,000 over 6 months. They can do this now with an optical microscope in our software. They can do in under a day what used to take them 4 months. So it's been great. So that same deep learning tech is made a big impact on the drone space, because a lot of those satellite image or aerial footage, drone image problems can be very, very complex, and they can involve, say, detecting components of a rail track over hundreds of thousands of miles of track in different shading and sunlight conditions, with different, you got rocks sitting on top of the track, and some of the components are kind of buried under the rocks. And being able to make an algorithm that can pick out the rails, the ties, the plates, the bolts, the the connecting bars, the bolts on those, and do what's called segmentation and recognize each of those different pieces in the image so that you can measure, how many there are, how many don't have bolts, where are there broken ties, where do the rails spread too far apart. That's a huge thing I'm learning in the rail industry, and automating that, which is now done by humans driving cars along the tracks twice a week. We've had really exciting early success with using the deep learning tech on that. And that's really pushed us to explore the drone space a lot more, because we know that there are countless other problems just like that, where there's no shortage of imagery, there's no shortage of drones out there collecting it, but we're learning that the hype around the automation that can be done with drones doesn't quite yet match up with reality. And the scale of those problems is so interesting, because the cost of flying these drones is sometimes, you can get a drone for 4 or 5 figures to do the work for you, but the value and the problem that you can solve with it can be in the millions. And that's a very exciting space for a growing business to be in. So the making a big impact, being adopted as part of a new standard for a particular automated inspection or inventory management process that involves us with drone imaging, being part of that go-to solution and getting the stamp of approval from a regulatory body, which basically forces then all customers in that space to adopt it. That's what our goal is for that space, is to be part of that type of solution. And it's getting pretty exciting.
That is really exciting. I mean, you shared some really astute insights on the life science industry as well. And it's exciting how you can how your software is helping to train people to understand image analysis techniques so much faster. It's just kind of a fundamental example of how well the software works. And now you're using deep learning to solve problems. I mean, I think finding the grains that aren't twins, I'm not sure if I even really figured that out as a material science student.
Yeah, it was not. I remember as an undergraduate, the first time they put one of those, was part of the first lab that, interestingly, Mipar is now a part of at Ohio State. It was the one. It was always used as okay, you've got to do it manual analysis sometimes, and you take out your pencil, you draw 5 lines across the thing, and you just try to count how many times an actual grain is intersected, and then you use that. I remember thinking it never even seemed remotely possible to automate that, because it was even hard for us as undergrads to figure out when to count across or not. And it was interesting kind of seeing the whole thing come full circle in a way, because that lab is kind of when I got my first exposure to image analysis ever. And then now where the software is being used in that lab today, and we just put out, an automated solution for the thing that we thought never could be automated, that is being used in the lab now. So that was a fun little point of reflection to kind of see the circuitous journey that kind of came full circle there. But that's just a tangent I'm getting on now.
And now you're helping make the advanced automated drones a reality, and you're saying it's not as easy of a challenge as everyone thinks to make the drones fully automated, but you're making huge strides with your deep learning and incorporating Mipar. I mean, that's so exciting. That's really it. Sounds like a great space to be in, and I wish you all the best. I'm sure you'll continue to achieve massive growth, maybe even faster.
No, I really appreciate it. And the latest hire that we had that I mentioned, the business, and he's on the business side of things. He fortuitously has experience in the drone space, and he kind of got brought on board right when this deep learning thing was happening, and we got connected with this rail inspection customer. So he's excited about that, and he's really helping push that forward. So that's great.
Perfect. Well, thank you, John, so much for sharing your story and your time with us. That we're about out of time now. Just to wrap it up, I wanted to ask if there are any calls to action you want to give the audience? Any information maybe for finding Mipar or any causes you're interested in?
Sure. I mean, folks are welcome to check out our website. We're mypar.us, or you just type in Mipar in Google and find us there. Like I mentioned, we have our free Learn Image Analysis course up on Udemy. The title is Learn Image Analysis. So you can just go to udemy.com and type in Learn Image Analysis and you'll find us, or the address is udemy.com/learn-image-analysis. And feel free to take a look at that and follow those lectures, and hopefully it's helpful to you in learning more of the fundamentals and applying those to complex problems. Those would be my recommendations or suggestions if you're in any way around the image analysis space. If you're ever someone who opened up ImageJ, some of that's probably for you. If this is all completely new to you and you're not really familiar with this space at all, I still recommend that you take a look at our website and look through we've got some neat little sliders on our applications page that you can slide across an image and see the before and after the software has detected the features, so you get a little more familiar with some of the areas that I've been speaking about. We do have, if you're working on any of these projects and you're struggling with anything, whether it's coming up with the algorithm or batch applying it or getting measurements out, our team is very willing to work with you. And we have avenues on our website where folks can submit images to us, and that'll start a process of working with our team to have us build a solution for you. Or we even have a mechanism by which you can, with our new deep learning tech, you can trace features on your images and just send those tracings to us, and we can cook up a model and show you the kind of thing that the AI can do. So if you think we can help, we'd love to meet you and learn about your work and your projects. And yeah, again, I really appreciate the time and the listeners, their attention, and it's been very rewarding, very meaningful for me to be able to share so many aspects of this story and kind of relive it myself along the way. So I really, really appreciate your invitation to join you today, Tyler. And I look forward, maybe we can do it again sometime.
Yeah, hopefully I'll meet you again in real life. And thanks for your time. And it really means a lot to me. You're thanking me for the podcast. It's really giving me the motivation to keep doing it. Thanks, John.
I think it's great what you're doing, and I know there's no shortage of folks out there with passion and very, very interesting stories of how they got to where they are that I'm sure would love a platform like this to be able to share those stories on. So definitely keep doing what you're doing, and I wish you all the very best. I hope this goes to the moon for you.
Thank you. Thanks, John. I wish you the best as well. Thanks for coming on. Have a great day.
Great. Thanks so much. You too.
Bye.